Nothing lasts forever, and so we depart October for the cold November rain. Still, everybody needs some time on secure code, which means this week we speak with Alfred Chung from Signal Sciences about the developer experience for bringing strong app security into Azure App Services. In the news segment, the curtain opens for an encore with Security Theater. The stage is set for data breaches from compromise, cloud, and now code. Previews for links means problems for privacy. The curtain closes on Flash, which I have to throw in a dramatic pause there because finally, wow. And more. Note the exits and stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more.
Welcome to Application Security Weekly. This is episode 128, which is episode 2 to the 7th, recorded 2 to the November 2020. That mostly works. I'm your host, Mike Shima. The role of co-host will be played by Matt Alderman. Hello, Matt.
Good morning, Mike. Daylight savings time's over, which means lighting will be fun. We'll see where the sun goes today.
We'll see where the sun goes. Speaking of which, the role of other co-host will be played by John Kinsella. Hello, John.
And John Kinsella is happy to report that we still have a sun in 2020, so, we got something good going for us.
We got something good going. Thank you for staying optimistic for us, John. While the sun is up, you have the chance to join Amit Bereket, co-founder and CEO of Perimeter 81, and Paul Asadorian for a technical deep dive into the problems inherent in legacy VPN technology. Together, they will explore solutions for the modern workforce and how momentum toward perimeterless architecture is helping redefine the future of cybersecurity. Register now by visiting securityweekly.com/perimeter81. Would you like to have all of your favorite Security Weekly content at your fingertips? Do you want to hear from Sam and Andrea when we have upcoming webcasts and technical trainings? Have a question for one of our illustrious hosts, someone from the Security Weekly team, or wish you could hang with the Security Weekly crew and community? Subscribe on your favorite podcast catcher, sign up for our mailing list, and join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. Alfred Chung is a senior product manager at Signal Sciences, responsible for modules and the product deployment experience. Prior to Signal Sciences, he worked on various enterprise security products in the endpoint security, vulnerability management, and application security spaces. Hello, Alfred. Thank you for joining us.
Hi, Mike. Glad to be here.
We're glad to have you here. And in fact, we've spoken, we've talked a few times with Signal Sciences, and you're focused on a really interesting angle here, the developer experience, especially in this case, as it pertains to the Azure App Services. But before we get into the Azure App Services itself, tell us a bit about what does it mean actually to focus on developer experience as opposed to, say, just pitching to a security team?
Absolutely. So at Signal Sciences, we have a very developer-centric sort of approach to security. Our founders came up with the idea for Signal Sciences at Etsy, which is, of course, the online sort of marketplace where, and also one of the kind of the leaders in DevOps back in the day. And what the founders saw in the market was, web protection platforms or web application firewalls that simply just couldn't keep up with the rate of change of applications that go through kind of the DevOps process. So when we talk about developer-centric, we mean having security protections for your applications that can be easily deployed by developers and DevOps professionals, and have that protection kind of stay with the application regardless of where it's deployed, and regardless of how often it changes or how often it's deployed.
So I'm kind of curious to poke a bit more about that aspect of deployment and developers actually, or the DevOps team actually doing the deployment, doing the management rather than the security team. And so does this mean that now the developers have to deal with editing a bunch of text files, whether they're YAML files, et cetera, or can they just work from Visual Studio, for example, if we're talking about Microsoft platform and Azure App Services?
Yeah, absolutely. So a month or two ago, we launched our Azure App Services site extension. So Azure App Services, for those who aren't familiar, is a platform as a service delivered on the Azure cloud. And this enables organizations who perhaps have legacy applications that they've written in Visual Studio to enable them to easily deploy them to the Azure cloud without having to manage an underlying web server or operating system. With the site extension, we've been able to package our Signal Sciences agent as well as our IIS module in a way that allows developers to deploy our web application firewall, or next-gen web application firewall, on applications and workloads hosted in Azure App Services with essentially a click. So although users of Signal Sciences may previously have had to install the agent themselves or the module themselves, at the command line, the site extension is a really exciting new option for our customers in that it really simplifies the deployment experience and gets them up and running with Signal Sciences more quickly than ever.
So and I want to also too, platform as a service is pretty compelling because it basically means that for, as you point out, I think these are possibly more like perhaps legacy enterprise scenarios, but you can deploy into the cloud and actually Azure is going to take care of all of the patching, all of the service maintenance, and you're literally just dropping your code onto a web browser stack. And in this case, now you're saying, you're describing how to put a, Signal Science, a WAF effectively on top of that to protect this legacy code, which, because we're using the magic word legacy, often has connotations for not necessarily the best written code or it's going to have vulnerabilities. But and so I mentioned too, like the Azure App Services can be self-patching, for example, manage it itself. There's also got to be a lot of sandboxing and other kind of constraints within app services that are actually very good security capabilities, security design. But what did you experience as you're trying to create a security service within app services and trying to work within some of these constraints of the sandboxing, for example?
Oh yeah, so Azure App Services, of course, is multi-tenant. So Microsoft has implemented a number of controls to ensure that workloads hosted in app services are secure. And for example, one application environment can't reach out to another application environment and steal or corrupt data. So these protections, of course, are a great feature for app services customers, but it certainly presented us with a technical challenge in that the way that our agent module architecture works typically requires some callback to the local host to enable communication between our module component, which is typically sitting on the web server, and passing requests to our agent that does all the decisioning and decides whether the request should be blocked or should be allowed to proceed. So because of the sandboxing implemented in the app services environment, there was no clear way for to install an agent and enable that agent module connectivity. The way that our engineering team was able to work with that constraint was essentially improve our module so that it had the ability to start and stop our agent and essentially launch it as a child process. And with that sort of processing or execution of the agent, we were able to avoid the sandboxing constraints.
So that's, to me, that's kind of interesting, hopefully to others too, is that going cloud native, just even more generally speaking, on the one hand is pretty easy at the application layer. This was sort of a lift and shift, if you will, for enterprises running on a .NET. They could just go into app services. But for you to provide that developer experience, to create a more seamless way to actually intercept the traffic, inspect traffic, it actually took you and your team some changes, architecture decisions, changes in code to make that capable. I'm curious too if you've seen that generalize a bit more into other types of cloud native services, whether they are just something Kubernetes in the cloud or even just service meshes, for example, to go sort of the opposite end of the spectrum, if you will, from even just the Azure app services.
Oh, absolutely. So at Signal Sciences, we have customers that kind of range across the entire maturity spectrum when it comes to application development, whether it's large enterprises that are trying to figure out how to protect their legacy applications that perhaps haven't been patched in some time or can't be patched because nobody knows where the source code is, to kind of startups, I guess, that are early adopters of some new technologies like service mesh and perhaps have been running their or using microservices-based architectures for some time. So in terms of developer experience, deployment experience, what I'm really focused on is ensuring that our customers across that maturity spectrum have a great experience when it comes to deploying our technology and is able to deploy Signal Sciences in a point in their stack that makes the most sense for them. So when it comes to our customers that are developing cloud native applications that are microservices based, and perhaps are getting so complex that they need to start looking at solutions like service mesh to help with the security and visibility of microservices traffic, that kind of east-west traffic, service-to-service traffic. We've developed an integration with the Envoy proxy, which Istio is based off of, and essentially allows our agent to use the Envoy proxy as a module. So whereas previously, you would have a separate module component developed by Signal Sciences passing requests to the agent for decisioning. With the Envoy integration, the Envoy proxy itself behaves as the module. And with that, it enables development teams to secure their workloads and their microservices, regardless of where they're deployed. So, a kind of a new kind of fundamental change, I would say, in application security when it comes to cloud native applications is that you don't always know exactly where the workload's going to be deployed. And thus, a lot of organizations are moving to kind of more of a zero trust model. Whereas in the past, developers would only deploy it to, say, their on-premises hardware. And that would be set up in such a way that would be protected by a firewall, web application firewall, and so on. But now you have teams that are deploying to not just on-premises infrastructure, but also to multiple public clouds, let's say. And how do you ensure that regardless of where those services are deployed, they remain protected? So with our Istio and Envoy integration, our protection essentially is deployed alongside the application, so that no matter if it's deployed to an on-premise server or to AWS or Azure or Google Cloud, Signal Sciences goes along with the code and protects it no matter where it's hosted.
Now, I'm curious too, because you mentioned, I want to go back a little bit. You mentioned that east-west traffic, that sort of service to service. And there's also, of course, north-south, the sort of the traditional kind of traffic direction from the internet into a web application. When we're looking at those, or when you're looking at those and talking with customers, do you see different perhaps threats coming in for those? Or are there different ways they actually have to approach and consider what the security problems may be from this so-called east-west traffic versus the north-south traffic?
Yeah, absolutely. So we've definitely seen a rise of interest amongst our customers to protect against threats like server-side request forgery, which of course was the technique used in the Capital One breach, where a malicious payload was sent north-south, but ultimately it was in that request being passed on to like a tertiary service in AWS that resulted in certain secrets being compromised. So whereas in the past, all the focus was really on ensuring that traffic coming from outside of the application into the application was protected and malicious requests were blocked. Now we're seeing that certain requests that are meant to compromise an application aren't necessarily compromising the application itself, but perhaps some service that is then being called by the application. So as you have these complex web applications being broken out into microservices, whereas before, if it was a monolithic architecture, you could kind of ensure that all the communications was trusted because it was all occurring within the monolith. Now you have services talking to other services, and these services might be hosted on different infrastructure platforms and so on. So how do you ensure that traffic is also secure? Because if let's say a single node in the cluster, your Kubernetes cluster gets compromised, that could be used as a jump-off point to compromise other nodes in that cluster. And because that's happening all behind the traditional application perimeter, those might be attacks that you are blind to. So having that east-west visibility, east-west security is something that we are starting to see more of an interest in amongst our customers.
Yeah, I guess that's interesting and ties strongly into what you're describing, that idea of zero trust within the product space, the product application security aspect. I'm kind of curious too, because we have been talking about service mesh, this type of east-west deployment. You're talking about breaking up a monolith into microservices. But I'm also curious too, have you seen organizations do that successfully? And if so, what are the type of organizations doing this? Because I am curious too that there's a lot of desire to perhaps break up a monolith, adopt a service mesh because perhaps it sounds fancy and new, or because it has some more concrete benefits. But it's, again, one of those easier things to say than it perhaps is to do.
Yeah, absolutely. Microservices aren't going to be the best architecture for all cases. It really kind of depends on what the needs are of the organization and kind of what the application's function is. I would say that we've seen customers, break their monoliths into microservices, perhaps because they wanted to create fewer dependencies amongst feature teams. So by having an application, let's say if it's an e-commerce application broken out into microservices, then you can have, let's say, one feature team working on the reviews microservice and another feature team working on the product catalog service. And they're able to operate and develop at their own pace with fewer dependencies and fewer likelihood of kind of conflicts arising when those two pieces of code are integrated into the overall application. So that's certainly a benefit of microservices, but the drawback that we're also seeing is just the additional complexity, which at times can beget more complexity, right? So you have an application that's broken down into microservices, and now you're not exactly sure, okay, where did that request actually end up? Did it end up at this microservice or that microservice? And the lack of traceability is, of course, one of the problems that service meshes like Istio has been designed to solve, as well as kind of like layer 3, layer 4 security and network segmentation, kind of having policies created so that only certain microservices can talk to other microservices.
Mm-hmm.
But what we've seen is that these service mesh technologies, although they do a great job of creating that kind of security policy, they don't really do anything at the layer 7, in terms of like OS POP 10 and that sort of thing. So that's where we saw an opportunity for us to work more closely or integrate more closely with those technologies to bring that layer 7 protection and visibility to microservices-based applications.
So with those conversations, then, we've been talking about developer experience from the very beginning, but I'm kind of curious, when or what role does the security team play in here? Whether it's these conversations about, this service to service layer 7 inspection and the same concerns about injection attacks, so to speak, or are they really just looking to see, or I guess I should phrase it this way, are you hearing from the developers who want these types of capabilities themselves, but they want to be able to do it in a way that is amenable to how they build and deploy software? In other words, they're feeling the responsibility and they're looking for solutions, or how much of it is still security team driving these types of capabilities?
Yeah, that's a great question. Actually, I had a conversation recently with a customer, and the person who I was speaking to is he's actually kind of more of an SRE, if you will, than a security team member. And he was the one that was really driving the conversation in terms of the need for east-west visibility and security. So I think there's actually some kind of like a bidirectional sort of conversation and education that needs to occur, because the security team may not be completely aware of the architectures being utilized in the applications that they are responsible for securing and protecting. And at times they just may not be aware that, there are these potential risks involved because the development team has decided to go to a microservices-based architecture. So I think what we're seeing is that it's more the developer side that they're kind of, because inherently they do care about security, although, the myth has long been that, developers don't care about security. I think that's something that's patently untrue. And it's really just a matter of communication and having a culture where security and development teams aren't so heavily siloed, and there can be an easy exchange of ideas between developers and security teams. Because again, the security team may not be completely or have 100% visibility into what the application teams are doing, and such it kind of rests somewhat on the application developer's shoulders to kind of bring up these concerns to the security team, and the security team will work with their vendors to figure out how can they actually implement these protections.
Alfred, my guess is a lot of security teams don't have a clue what's going on with the architecture of the application. So I think it's interesting that you're seeing the SRE team. Is that a replacement for what was traditionally kind of the architecture team? Site reliability engineering is kind of that new evolution of architecture and managing these complex applications going forward on the dev side of the house?
Well, in this particular customer, this SRE, he has become involved with Signal Sciences because he ultimately has to manage and monitor the health of the agents that they use to protect their web applications. But in doing so, I think that's kind of how he became sort of more familiar with how the development teams were building their applications and where these agents were being deployed. So would the SR team, is it always going to be the case that the SR team is going to be pushing for these changes? I would say it kind of depends on sort of the maturity of the organization. But oftentimes I would say, like in these more forward-thinking DevOps organizations, you do see that close collaboration, of course, with developers and SREs, and thus I think it'll be the SRE, but at times I've also seen the architect for sure, because the architect really should have kind of the full visibility of what's going on there.
Yeah, it was an interesting use case, right? Because we've been talking about site reliability engineering as kind of this new way to think about these applications, right? But to have the security conversation come from the SRE is actually a very interesting use case, because they have to understand the complexity of that application. They're also in a really interesting position, I think, to also understand some of the potential aspects from a security perspective. Does security start to come under the SRE organization in the future?
Right.
Because these are the guys that are trying to make sure everything's running reliably in production.
Yes, absolutely. I mean, I think for the SREs, their primary responsibility, of course, is going to be reliability and performance, right? I mean, that's in their title. But security is also a very critical part of their job. So, for example, at Signal Sciences, a lot of times when it comes to just like auditing the IAM roles in AWS and ensuring that we don't have any roles sitting around that are being unused and don't have and have more permissions than they really should, these are things that our SREs are actually spotting and bringing up. So it's although it may not be the primary responsibility of the job, I'm finding that like they have the visibility and the curiosity to say like, hey, is that configured correctly? Do we have the right protections in the right places?
Yeah, I like that. Go ahead, John.
Sorry, I was just thinking it's an interesting way to think about this too, because I think historically, and it's funny because we're going to talk a little bit about this in the news, I think, but historically we've looked at as security folks, we've been trying to get into those initial design meetings with the developers. And sort of what you're saying in a way is, I know you're thinking SRE, but it's almost either SRE or dev, if I can put those two into one bucket for a second, and say they're demanding the security people to be in the room with them so that they have more understanding of what's going on.
Yeah, absolutely. Because it's oftentimes the security team will have invested in a number of products that are already in use, and it may be from working with those products or just or coming up with these new use cases, and sharing them with the security team, that the security team realizes, oh, like perhaps the products that we have don't really kind of fit the needs of our organization because our needs have changed. So, I think, at Signal Sciences, like a lot of our customers are kind of on the more sort of forward-thinking end of the spectrum, and we are seeing a lot of that close collaboration between security teams and development or SRE teams. But it's still something that I think that perhaps in the enterprise is something that's still kind of evolving and still there's some opportunity there. When it comes to when you have that collaboration and that communication, I think there's just more trust, and ultimately it's just kind of win-win. Security team, they get to get more visibility into the potential areas in which there are vulnerabilities that they didn't know existed, and the development team and the SRE teams get to deliver on a product that ultimately doesn't just work better, but is more secure and ensures that that the end users are protected and the company is protected.
Yeah, and I wanted to add, I really liked how the direction this was going to talk about, and you mentioned too that the SRE is concerned about the health of the application, and health definitely, I think, could have an umbrella of security, resiliency, availability, of that CIA triad, something we actually talked about last week. So I'm curious too, are they also looking for capabilities for features of something like Signal Sciences to give them more feedback about the health of the application beyond just an injection attack, a SQL injection or something like that? And instead, they could look at availability or rate limiting even, or these types of scenarios that are pretty important to the health, the uptime, and performance of applications.
Yeah, that's interesting you mentioned that, because we do have some customers who do use Signal Sciences for what would be more traditional like application performance management use cases. It's really because boils down to like how our solution is architected, and the fact that because we're essentially in line of the request, and we get that request before it actually hits the workload or the application. We can give these performance teams, these reliability teams, insight or visibility into like 404s or other 400 errors before their APM solution can. So although that's not necessarily our kind of primary objective as a security company, it was one of the sort of the nice benefits, I guess, of how we were architected. That we can provide additional visibility and show that there's an issue perhaps a bit faster than a traditional APM would.
That's pretty cool, because hopefully the narrative that emerges there is not the security team saying, hey, just go put this security device in front of your application because we need to tick a checkbox, but it's more of, guess what, you'll actually get some benefits about some basic performance, some basic engineering important metrics that come from, just so happens, this particular security solution. So to me, that sounds like a really great way for modern security products to try to aim for, to design themselves for. And I think, Matt, I stepped on something you were going to say.
Yeah, I mean, because of the rate limiting capabilities that Signal Sciences has in the platform as well. Think about this, right? You can see which endpoints are being hit via APIs, where potential abuses. These all have a potential performance impact and a security impact. And that's why I think it's interesting to have not only the security capabilities that you do, but some of that performance data is actually very relevant to the application teams, the SRE teams, for example. And so I can see that crossover being very relevant for people who are thinking that way.
Mm-hmm. Absolutely.
Yeah.
Yeah, I think it kind of goes back to Mike's comment about security being a part of quality, right?
Mm-hmm. And so speaking of, I just trying to come up with a good segue for security and quality, but maybe I'll just turn it around to, as we go back, we started talking about Azure App Services, so making things easier for developers, especially if they're wrangling legacy software, try to make their lives easier. Any final thoughts or comments, or advice for developers moving into an Azure App Service or trying to deal just with legacy applications in general?
I would say that, web application firewalls, don't think of like web application protection as primarily like a networking security concern, which has traditionally been, where WAF has kind of been owned, I guess, in the past. There are newer innovations, newer technologies being developed to protect applications or workloads that will work with your existing development workflow. And this actually also kind of benefits the network team in a way, because if you deploy your WAF or your web protection at the application layer, then that is kind of one less component, I guess you can say, from the overall networking architecture that could potentially fail or break or cause issues. So when we were pilot testing our Azure App Service site extension, a customer had mentioned that they love the ability of being able to deploy the app level protection with the application, because it was one less thing that they needed to troubleshoot when they ran into issues, which previously they were deploying WAF as kind of more as a gateway. within their network architecture. And now, since it's deployed on the application, if they're seeing some issue, perhaps a request is not making it to the application for some reason, they're able to easily count out or discount Signal Sciences, because they can just simply turn it off at the application layer rather than taking out something in the whole request flow in their networking architecture.
Oh. Well, you've definitely taken us out on a journey through the cardinal directions of cloud environments. So I want to say thank you for this chat, Alfred.
Oh, thank you. It's really great talking to you guys.
Also want to thank Matt and John, and thank all of you for listening. To learn more about Signal Sciences, visit securityweekly.com/Signal Sciences. We'll take a quick break now and return with news of the week.